In last class, we have seen chi-square goodness fit test. So far, we have seen z-test and t-test. They are used to compare mean values. Today, we will see f-test. By using f-test, we can check two normal populations have same variance or not. Suppose if you want to compare two brand refrigerators, we can consider one with less variance as consistent brand. Like if they give 10 years warranty on compressor, if it works without any problem up to 9 to 11 years, it will be considered as good one. If compressor durability is from 5 to suppose 13 or 14 years, we consider it as less consistent. Means the one which have less variance is considered as good one. In this kind of situations, we might require to compare variances. F test is based on F distribution. So let's see F distribution. F distribution was developed by Ronald Fisher to study the behavior of two variances from random samples taken from two independent normal populations. Let u1 and u2 be chi-square random variables with d1 and d2 degrees of freedom respectively. If u1 and u2 are independent, then a random variable x u1 by d1 divided by u2 by d2 will follow f distribution with d1 numerator degrees of freedom and d2 denominator degrees of freedom. We denote it as f of d1 comma d2, means f distribution with degrees of freedom d1 and d2. Probability density function PDF for random variable x is given by this formula. Here this one is the gamma function. We do not use this PDF. Instead we can use f table like t distribution and chi-square distribution. With degrees of freedom, f distribution will also change. For numerators degrees of freedom 1 and denominator degrees of freedom 1, the f distribution will look like this red curve. Like this, for different d1 and d2 values, f distribution will change. The random variable of f distribution can also be written like this: s1 square by sigma 1 divided by s2 square by sigma 2. Here S1 square is the sum of squares of D1 random variables from normal distribution. S2 square is the sum of squares of D2 random variables from normal distribution. Means both S1 and S2 are two chi-square distributions with degrees of freedom D1 and D2 respectively. F distribution is non-symmetric distribution. Shape of the distribution depends upon the degrees of freedom values D1 and D2. F distribution is used in analysis of variance test to test the mean values of multiple groups. Let us see F test. F test can be used to check whether two samples come from population with equal variances or come from populations with different variances. Let us see one example. The dataset contains 480 ceramic strength measurements for two batches of materials. The summary statistics for each batch are shown here. Batch 1. In batch 1, number of observations is 240. Its mean is 688.99 and standard deviation is 65.5. In batch 2 also, number of observations are 240. Its mean is 611.15 and standard deviation is 61.8. You need to test whether two batch variances are equal or not. First we need to formulate null hypothesis and alternate hypothesis. H0 sigma 1 square equal to sigma 2 square. Alternate hypothesis H1 sigma 1 square not equal to sigma 2 square. Null hypothesis will say that two group variances are equal. Let us assume significance level alpha 0.05. Here we want to know two samples come from populations with equal variances or they come from populations with different variances. Here F test is appropriate, but F test is based on normal distribution, so let us assume population follow normal distribution. But when you are performing this F test on real data, you have to check whether that data is following normal distribution or not. But here just we are learning. So let us assume population follow normal distribution. F statistic formula is S1 square by sigma 1 divided by S2 square by sigma 2. Since null hypothesis is two variances are equal, so F statistic will be S1 square by S2 square. Then substitute first batch standard deviation S1 and second batch standard deviation S2. Then their variances would be 4290.25 by 3819.24 and F statistic would be 1.1233. To find the critical value, here degree of freedom for first batch is 239, degree of freedom for second batch is also 239. We choose alpha 0.05. We can check critical value in F table, but our degrees of freedom 240 and 240. Here 240 is not there, means degrees of freedom values are large. So if we calculate the values using any software, then lower bound will be 0.7756 and upper bound will be 1.2894 for these degrees of freedoms 239 and 239. We need to compare this F statistic with F critical value. Here F statistic not within the rejection region, means result is not significant, so we cannot reject null hypothesis, means two batch variances are equal at 0.05 significance level.